Now we're going to look at more application-based situations in which we would use the Pythagorean theorem. So this is just at the bottom of where we took those notes. I'm just covering it up so that I don't feel overwhelmed by those problems. I'm going to read this. So this problem says, Gigi's family left their house and drove 14 miles south to get to a gas station and then 48 miles east to a water park. How much shorter would their trip to the water park have been if they hadn't stopped at the gas station and had driven along the diagonal path instead? Remember, that was my first step, is to just read the problem all the way through. My next step is to read through it again and identify the information that is known. So Gigi's family left their house, so we were at their house, and drove 14 miles south to a gas station. So we are at the house and we drove 14 miles south. And if you don't know your directions, here we go. Never eat soggy waffles. Northeast, southwest. So we went 14 miles south. And then 48 miles east to a water park. So from the gas station, we went 48 miles east. How much shorter would their trip to the water park have been if they hadn't stopped at the gas station and had driven along the diagonal path instead? So now they're trying to compare this route, which we traveled a total of 14 plus 48 miles. So their original timing was 14 plus 48, which gives me 1262. So that was our original total mileage. Now, instead, they're saying that we go directly from the house to the water park. And we want to know how much shorter that would have been. There's no new information here. This is what they're asking me. So now I'm looking for the unknown. I need to find out so that's my question that I just labeled. My first thing that is unknown is the distance is from house to water park. But that's not what the question is asking. They're asking how much shorter this number is than the original 62 miles. So we have a couple of steps we need to follow. But first, we're going to use our steps from up here. So we have our triangle drawn. We have not labeled our longest side, so let's do that. My longest side is going to be red just to keep everything consistent. So the distance from the house to the water park, that is my hypotenuse, that is my longest side. I have labeled that C. My next step is to label the other two sides A and B. So we are going to label A and B. A, B. Now I'm going to write my formula and plug in and solve for the missing variable. In this case, what I'm missing is C. So just like we did before, let's write out the equation first. So we've got A squared plus B squared equals C squared. I'm going to write these parentheses directly beneath it. And then I'm going to plug in my known numbers and my unknown variables. So I know A is 14, B is 48, and C is our unknown. I am going to find 14 squared plus 48 squared, and I'm going to get 2,500 equals C squared. We're not done because right now my C is still squared. I want to get rid of this little squared, so I have to take the square root. The square root of 2,500 is 50, so that means C equals 50. I'm not done. This is just giving me the number of miles from the house to the water park. That's not what my question is asking. The question says, how much shorter would their trip to the water park have been if they hadn't stopped at the gas station? So if they had just driven from here to here, how much shorter would it have been? So we have to do some subtraction. The original distance was 62 miles. The direct distance is 50 miles. So it is 12 miles shorter than that original distance. So now I am done. Okay, so the other type of problem that we can have that's application based for now for the Pythagorean theorem is they can actually give us a triangle and ask us if it's a right triangle. If it's a right triangle, then the side lengths will follow the Pythagorean theorem. So if it is a right triangle, the sides will follow the rule a squared plus b squared equals c squared. So in order to prove if it's a right triangle, this has to hold true. So what we're going to do is follow those same steps we did before, but we have to realize that we're just making a guess at where the right angle would be if it is a right triangle. So in this case, 12 has to be our C because 12 is the biggest number, which means that the right angle is directly across from it, which means the other two are A and B. If those are A and B, then I can plug these into my formula. A squared plus B squared equals C squared. We know to add these parentheses so we don't make any mistakes. I know that A is 6, B is 8, and C is 12. What's in question right now is whether or not these statements, these expressions, are equal to each other. If they are, then it is a right triangle. If they are not, then it is not a right triangle. So let's see. 6 squared is 36. 8 squared is 64. And 12 squared is 144. I know that 36 plus 64 gives me 100. 100 is not equal to 144. So this triangle is not a right triangle. So we will do one more example of this, and I'm going to use these numbers down here. So we actually have to draw our triangle in this case. I have a potential right triangle where this would be my right angle and this would be my longest side. The biggest number has to be my longest side, so 7.5 has to be C. and then 5 can be A, and 2.5 will be B. I'm going to write out my equation. A squared plus B squared equals C squared. I'm going to plug into my equation. Oops. Okay, pretend that's a parenthesis. I know A is 5, B is 2.5, and C is 7.5. I'm going to plug in these numbers on my calculator. Well, I know 5 squared is 25. We know 2.5 squared is 6.25. And then 7.5 squared is 56.25. I need to add 25 plus 6.25, and I get 31.25. And now I'm thinking, okay, are these equal to one another? No, they are not equal to one another. So they are not the side lengths of a right triangle. They're just the side lengths of a random triangle, but this triangle is not a right triangle. I have a few more example problems on this page that match these applying the Pythagorean theorem rules. What I will do is solve them not on the video and then put them up and just quickly talk about each one. So my recommendation would be to do them on your own and then check with the video. So like I said, I'm just gonna really quickly go over these. I've highlighted the known information and in yellow and highlighted the question in purple, but essentially this question says Peter is trying to get his cat out of a tree in his backyard. The cat is 12 feet above the ground and Peter has to put the base of the ladder 9 feet away from the tree because of mud. How long does the ladder need to be in order to reach the cat? So I drew a little picture. We know the height of the cat in the tree, the distance the ladder must be placed from that tree, and then that the ladder is going to be leaning against the tree to get the cat. This is a Pythagorean theorem problem because this is our right angle right here, which means that the length of the ladder is C. I'm going to solve, and the ladder should be 15 feet long in order to reach the cat. The next word problem gives me a tent. It says the front view of a tent is shown below. If a zipper is going to be put in along the length of X, how long should the zipper be? What we need to realize in this problem is that this original triangle is not a right triangle. But where the zipper is, that creates a right triangle if you cut the base in half. So half of 16 is 8. So I know that the right triangle I am working with is going to have a base of 8, a hypotenuse of 17 feet, and then the unknown is our A. We use the Pythagorean theorem and we solve and we get X, our missing length, the length through the zipper. It ends up being 15 feet. And then our two triangles down here, when I solve both sides, I get a right triangle for this first one because A squared plus B squared equals C squared in this case. They're both 650.25, so it is a right triangle. And then the last one, could the side lengths below form a right triangle? Yes, because A squared plus B squared equals C squared, because 3,721 equals 3,721. So I know it follows the Pythagorean theorem, so I know it is a right triangle.